Hi, my name is Muhammad Nassim. I am from Information System student, semester 1, 2017-2018. I am also student of Dr. Zeti Akmal Bitira Dali from section 3. I am from group number 4, which the task given is question number 4. These are our group members. They are consist of 2 EP student, which is electrical power student, and 3 E student, which is electrical electronic students. The objective of this project paper is to answer all the tasks given by the lecturer. Of course, we want to answer it correctly and precisely. Second, we want to be inspired and making a good teamwork with members. We are from different courses, so we want to make new friends and share knowledge. Third, we want to learn and understand function of MATLAB software. MATLAB is usually used in electrical students, so we want to familiar with it. And lastly, we want to separate works to each member equally. Since I want to highlight that we want to develop our soft skill. For question number 4 given is this question. All the parameter is given. So now I will discuss to you about part A. Part A, we are required to determine the modulation index and draw the power spectrum. Based on parameter given and some calculation, we are also required to simulate the complete FM system using either MATLAB programming or MATLAB simulation. For part A, we want to use MATLAB programming because it is more easier. This is the calculation for modulation index, all the parameters given. So we find that FM is equal to 40 kHz, FC is equal to 500 kPh. For P1, we use the equation P is equal to V square over 2R. We get V1 equal to 5.8 volt and V2 is equal to 3.5 volt. We use the same equation. So we get V1 and V2. We know that from the basic table we can get the modulation index. So we find the J value, which we use the equation V is equal to VCJ. We get J1 is equal to 0.58. We don't need to use J2 because we use J1 is also valid. So we know the modulation index is equal to 2. This for task number 2, this is the power spectrum. For task number 3, this is MATLAB simulation. This is coding for the simulation. We split it in 2 pages because it cannot fit in one page. For task number 4, this is output waveform. For task number 5 this is the frequency spectrum. So we calculate the VM value is equal to 4 volt. Delta F is equal to 80 kHz. So this is all the value that we calculate. And lastly, this is the frequency spectrum that we get.
Moving on to the question number 4 part B. Here we are asked to double the bandwidth obtained in part A, and then we will demonstrate it using MATLAB and display the frequency spectrum. Next, we are required to determine the new total transmit power when the modulated signal is limited to 20%, and then we are required to multiply the modulated signals using FDM and simulate it by MATLAB. So here we can see for the first part is the original frequency spectrum obtained by using this coding in MATLAB. So when it is double, here is what we get. The new frequency spectrum for when the bandwidth is double. So how do we do that is by using this code, simulate in MATLAB. So for the next part is the calculation for when the modulated signal is band limited by 20%. We get a new value of n, which is 6.4, and from that we calculated a new total transmitted power, which is now equals to 2.55 watt. And for the new bandwidth, which is equal to 6, our bandwidth is now 480 kHz, ranging from 240 kHz until 720 kHz. So moving on to the next step is simulation of FDM system. Here we can see our schematic diagram, which we draw in by using MATLAB. Here is the output waveform that we can get. The first one, the top one we can see is the message signal. The second one is the modulated signal. The third one is multiplex signal, and the bottom one, the most bottom one is the demodulated signal. So as for conclusion, we succeed to achieve the main objective, which is to design a communication system by using MATLAB software. In part A, we were able to generate modulation and demodulation signal, and we can see that the demodulation signal is the same as the original message signal. As for in part B, the modulated signal was band limited by 20% and the bandwidth was doubled. This will result in doubling the amplitude of the output. Finally, we can see that multiplexer gives us the advantage to increase the number of channels so that more data can be transmitted. Lastly is the members' contribution. For part A, the calculation part was done by Aiman and it was then checked by each of the group members. Then after the calculation part, the simulation part is done by Haikal and Hakim. Same goes for part B. The calculation part was calculated by Aizat and Nazirul, and the simulation part was done by Haikal and Hakim. And lastly, the video was shot and edited by Haikal and Hakim. That's all. Thank you.